Okay, ceramics. I'm not going to go into a lot of detail about this. You can read about it in the textbook. But ceramics are traditionally defined as inorganic, non-metallic solids. They're prepared from powders mixed with water that are heated. And when that occurs, chemical bonds form. There's a chemical reaction that forms the ceramic. There are different types of ceramic. Silicate ceramics, aluminosilicates. So you've got aluminum and silicon with the oxygen. Clay is a natural form of the silicate, and if you mix it with water and heat it, you can form a ceramic. The characteristics of the ceramic are going to depend on exactly what type of clay you have. Kaolinite, as an example, has this structure or this formula, and it undergoes irreversible chemical structural changes when you heat it above 1500 degrees. So you can't undo the firing of a ceramic object. So kaolinite is the most important component in porcelain. Porcelain originated in China, and that's why we often call the nice dishes that you might use tomorrow at Thanksgiving dinner the good china, right? Because they're actually porcelain. You can have oxide ceramics, so there's no silica in these. There's no silicon. We've got aluminum, oxygen, magnesium, oxygen. And these all have different uses. Porcelain, especially if it's thin, can be very fragile. Others are going to be sturdier. These can be used as high-speed cutting tools. The little, not the glass Gooch crucibles, but the little ceramic crucibles. Those are made out of an oxide ceramic. It can withstand an extremely high temperature. You can also have non-oxide ceramics, which have no oxygen. And so here's a couple of examples. Yeah, you can read that. I'm not going to read it to you. Cement. The Romans were the first ones to use cement, and they mixed lime, volcanic ash, and clay with water and made this, horrible slurry. When it dried, it got extremely hard. And it wasn't just that the water had gone out of it, a chemical reaction occurs, and so once the cement hardens, you can put it in water, put water on it, it will not go back. It is an irreversible change. So a very useful form of cement is called Portland cement, mostly limestone, calcium carbonate, silica, sand, SiO2, and then it also has a little bit of alumina, iron 3 oxide, and gypsum. And this is going to react with water. There's a number of different very complicated reactions that occur, and you get a rock-like substance. So there are formations of silicon-oxygen-silicon bridges that make fibrous structures within the hardened cement, and that's what gives it its strength. Concrete is different than cement. We often use the words interchangeably, but cement is actually concrete is a combination of cement with added sand and gravel. It's the most common building material in the world. It revolutionized how structures are created. The building that we're in right now is composed largely of concrete. Glass. Again, these are all covalent atomic solids. Glass is also a covalent atomic solid. So you can melt silica, high temperature, but you can do it. So above 1500 degrees, it will melt. If you cool it quickly, the silicon and oxygen atoms will form an amorphous structure instead of a crystalline structure. And we call that glass. Silicate glass is transparent, it's impervious to water, it's great for windows and drinking glasses. The Romans also developed glass making. What they found was if you add sodium carbonate to the silica, you can reduce the melting point. And so this makes working with the glass much easier because 1500 degrees is kind of hard to get to. So with the sodium carbonate, you have a lower melting glass, and then you're able to do glass blowing and bending and making different shapes. Vitreous silica or fused silica is a glass made from just silicate, SiO2. So it's very hard, resists high temperature. It's got a low thermal expansion, meaning when you heat it up, it doesn't expand very much, so it doesn't shatter with temperature changes. It's transparent to visible and ultraviolet light, which you may or may not want. But because it has such a high temperature at which it melts, it's very expensive to make. So soda lime glass, also called window glass, this has, again, silica, but also sodium oxide and calcium oxide. It's also transparent to visible light, but not to ultraviolet light. So this is good because it's going to filter out the ultraviolet light so you don't get a sunburn. It does have a high thermal expansion. So it's going to expand a lot when it gets hot, and therefore it'll be subject to shattering. It's much less expensive to make, and you can blow it into all kinds of cool shapes. And then we have borosilicate glass. The trademark name is Pyrex, which you've probably heard of. This has boric oxide in it instead of calcium oxide. This has a much lower thermal expansion, and so you can heat it and cool it without shattering. So most of the glassware that we've been using in the lab, especially everything that we've been heating, is all made out of Pyrex because you can heat it and cool it and it's not going to shatter. Leaded glass, which we usually refer to as crystal, contains lead oxide. The addition of the lead gives it a higher index of refraction, which is what makes it more sparkly and brilliant than regular glass. It also makes a ringing sound when tapped, so you can, you look at two different wine glasses, one made out of glass and one made out of crystal. The crystal one is just going to look more sparkly, and if you tap it, it'll give you a much better ringing sound than you would get from just one made out of glass. Of course, with the lead in there, you've got some issues. Back long time ago, they would store their liqueurs in leaded glass crystal decanters, right? And it leaches the lead into the liqueur, and then you drink that, and you get lead poisoning. Not good.